Good afternoon, everyone. Welcome to day 2 of Global Summit. You're like 3/4 of the way through day 2 of Global Summit, but I'll welcome you anyway. My name is Bob Kuszewski. With me is Patrick Jamieson.
Hi.
And we are doing a session today called FHIR in the Cloud. Our goal today is to take a number of really very large topics and just stitch them together. We're going to be taking a Kubernetes cluster, we're going to build one, we're going to configure it, we're going to install Iris for Health on it, we're going to install FHIR on that Iris for Health, and then we're going to pull it all together with OAuth so that you have a full OAuth managed FHIR server running in the cloud all in 45 minutes. So to do that, we're not going to go into depth on any of those topics. We have, I think, 57 FHIR sessions at Summit this year. I know we have at least 2 on OAuth. We did a couple on Kubernetes last year. I'm sure we'll do a couple more on Kubernetes next year. But the goal here is to be able to walk away with not the right answer for how to get from nothing to, hey, I've got a production-ready FHIR server, but it's enough to give you a starting point, give you things to think about. That's what our goal is for here today. You can follow along with what we're doing. We produced a GitHub repo that has all of the scripts and the YAMLs and the discussions of all the things that we are doing, because we're going to go really fast through some of this. So part 1 is we're going to create the Kubernetes cluster. Should I tell them now that I cheated?
Sure.
Okay, I cheated. I created it half an hour ago. And then Pat's going to walk us through an overview of AWS and Kubernetes in AWS. And then I'll walk us through kind of using Iris in Kubernetes, configuring that, and setting up Iris and Iris for Health. And then we'll go through securing with OAuth. Pat will take care of that. So with that said, Pat, you ready?
Yeah.
All right.
Thanks, Bob. How many in the audience here has worked with AWS, has any cloud deployment, healthcare or otherwise? Few? Good. How about Kubernetes? How many of you are Kubernetes users? Oh, great. So for those that don't know, I'm going to give you a very quick overview, but this won't teach you everything you need to know about Kubernetes. But let's talk a little bit about going to the cloud. What are some of the advantages? And I'm going to run through this quickly. You saw in the keynotes, we could have scalability. You could manage your FHIR servers and scale them up or down depending on demand. You can have a lot of control when you are managing a Kubernetes cluster of deploying only those components you need. So it could be quite cost effective. You could shut it down, for example, if you're not using it. Probably the biggest advantage is accessibility. With cloud-based FHIR servers, you could set up an endpoint on the internet and make it easy to collaborate with others. And running on the AWS infrastructure, it's very secure. With our Kubernetes deployment, we also have end-to-end encryption that makes it very, very secure. Cloud-based FHIR servers can be easier to maintain. At least the cloud provider provides updates to the operating structure, infrastructure, and other parts of the infrastructure. So there's a lot of advantages to running Kubernetes in the cloud in terms of deploying your FHIR server. Now, I'm not going to get into this in detail, but InterSystems offers both managed and unmanaged FHIR cloud services. So with managed, you deploy in the cloud, but you really are part of monitoring, logging. You're doing some of this. We're doing some of the services. You're doing other parts. It's a kind of a shared model. With unmanaged, you really effectively creating all the resources yourself. You have to then know all about security, SSL certificates, etc. So this requires more knowledge and skill, but gives you the greatest amount of control. So for those that don't know what Kubernetes is, it's an open source container orchestration system. And what's nice about this is that this makes it easier to do software deployments, scaling, and management. Google initially designed it, but it's now part of the Cloud Native Computing Foundation that maintains the project. And you might see this abbreviation K8S. It's just the 8 letters between K and S in Kubernetes. So why would you use it? Again, it makes it easier to run containers in the cloud and do a whole lot of different deployments. It's very scalable. So you effectively give Kubernetes commands, you tell it what resources you want, and the controller in Kubernetes then makes sure that it maintains the cluster state the way you've designated. It's very portable. So you could go from one platform like AWS to Azure, and so it moves very, very easily. It's designed for resource optimization, and you can very much scale and efficiently scale your applications and make sure they're always available. It's very automated. It's a declarative language that makes it very easy then to move from one source to the next and to make changes that then can be propagated into the cluster. And it's self-healing. So if part of your cluster goes down, it can basically restore it. There are a lot of objects in Kubernetes. We don't have time to talk about them all. The most important is the pod, which is the smallest and simplest unit in Kubernetes. It represents essentially a single instance of a running process in the cluster. You also have services. This is an abstraction layer that provides a stable IP address and DNS names for a set of pods, so services allow these applications to talk to one another. You have a deployment object that manages the creation, scaling, and updating of the pods. Config maps and secrets. These are objects that make it easy to essentially share sensitive information such as API keys, database passwords, without revealing them to others. The config maps also provide ways of configuring your cluster. So here's some useful Kubernetes commands. We're not going to get into them all, but effectively at the command line, you could type in these commands to get a lot of useful information about what's going on in your cluster, like what pods are running. You could get a very detailed description of the pod or the other objects in the cluster. You could effectively build kind of what's called a manifest file and apply it. And Kubernetes, the controller, will respond and deploy those resources for you automatically. You could obviously delete resources with these commands, and you can get log information when things break down. So here's a couple of the building blocks you could see in a cloud cluster. So you have nodes. These are physical or virtual machines that runs the Kubernetes hardware and host. And so this is the most basic building block of a cluster that contains your pods, which is the smallest deployable unit in Kubernetes. We've mentioned services. Controllers are a great tool for managing the desired state of the cluster, ensuring the correct number of pods are running and scaling them up and down. And I've mentioned about config maps and secrets. These are ways to configure the cluster very easily in a declarative way. Also, Kubernetes, to use it in a persistent way, which you need with FHIR, you have to have persistent volumes. And the way this is done in a Kubernetes environment is through persistent volume claims. To make it easier to use Kubernetes with AWS, AWS offers what's called the Elastic Kubernetes Service, and this is a wonderful service that makes it easy to really deploy all of the different components that you need. These include things like gateways, load balancers, and DNS updates to Route 53 to make your cluster accessible. So overall, EKS is something that if you're going to run it in AWS, you should learn. And this is just giving you an overview, kind of what are the components. You have an EKS control plane, that's not plan, and then the different worker nodes. The control plane really manages those worker nodes to effectively deploy your specific implementation, including things like the FHIR server. You could check provisioning of your cluster. We're not going to go into that. Again, here's a way we can describe the different pods. AWS offers the opportunity to understand exactly the compute characteristics, the memory, and the pods that are running in your cluster. InterSystems has also made it easier to deploy with Kubernetes through a special operator that Bob will talk more about, called the InterSystems Kubernetes operator. What this does is take the resources or the components in the InterSystems architecture in terms of things like mirroring and ECP and others, and makes it very easy to develop a declarative manifest of these things so that you could launch with Kubernetes in a much easier manner. So here's an example at an overview level of a FHIR cloud architecture. So we see Kubernetes is talking or configuring a FHIR server, and it's also at the same time configuring load balancers and not depicted here, also DNS entries so that your FHIR server can be found on the internet. With Route 53, you can talk to your FHIR server by giving it a domain registration, and you could get a digital certificate either through AWS or others, and then be able to really securely have TLS traffic running between any client and your FHIR server. I'm not going to go more into that, but it's very inexpensive to get a get a domain name that you could tie to your load balancer and get an AWS certificate so that you can secure the traffic to your FHIR server. These are some of the components that you would need. You need a load balancer, and we provide that in the manifest you'll see today. We also have set up internal TLS SSL from the web gateway to Iris for Health. Why do we need that? Because the OAuth server requires all traffic to be encrypted. And so essentially, if you're going to have a FHIR server in the cloud in production, you need to have end-to-end encryption, not just encryption to the web gateway, but encryption at the level between the gateway and the FHIR server. So that's inside AWS's networking. So at this point, Bob, I think time to create and configure a cluster.
All right. So now we're going to get into the part where we actually walk you through, hey, what do you need to do to set up a Kubernetes cluster, install it, configure it, get a FHIR server up and running on it, all that stuff. So there's a few prerequisites that you will need. You'll need a few tools installed on your machine. Those are on the left-hand side. EKSCT. This microphone? I should use this microphone. I'm getting signals. Is this the microphone you want me to use? All right. Is this better? All right, cool. Sorry about that. EKSCTL, these prerequisites on this page. EKSCTL gives you a command line tool for creating and managing EKS clusters. So AWS's Elastic Kubernetes Service. If you are using OpenShift, or if you are using Azure Kubernetes Services, or any of the other Kubernetes that are out there, they all have equivalents of this. The specifics and the mechanics of it are going to be a little bit different, but just for this demo, this is the one that we're showing. You'll need the kube control, which is the command line tool to interact with Kubernetes. You'll need Helm, which is the Helm. Helm is a package manager for Kubernetes. And since we're using AWS, you'll need the AWS command line interface. For this demo, we're also going to be using DNS to create SSL certificates and to give a domain name to our cluster. So for that, we'll need a hosted zone in AWS Route 53. As I said before, I put the link up here so that you can follow along and take a look at this as you go. So the first thing that we're going to do, which I already admitted I cheated on and ran right before this meeting because it takes 20 minutes to run, is to create an EKS cluster. You can configure really all aspects of a Kubernetes cluster, like which worker pool that you want. What are your nodes? In Kubernetes, the physical machines that work gets assigned to is called a node. And you could have those be auto-scale groups. You could have different types at different sizes, what size machine you want. That's usually a price performance question that you want. One of the great things that EKS now has is connection with AWS IAM roles. In the past, getting IAM, getting your EKS cluster resources to interact with AWS really meant opening up a lot of security holes, and they've fixed that. All right, so moving on. So running this takes about 20 minutes. The command is right at the top, the EKSCTL command. And I will show you that I just did that. I copy and pasted from my copy and paste instructions, and over on the right-hand side, you see that it does all of the creation of the cluster through CloudFormation. So let's move on to the next thing. The next one is another Kubernetes application. Now we have a cluster, and we are going to install a very simple Kubernetes application that we didn't write that's called external DNS. What this will do is it will allow you to have a Kubernetes service. You can annotate it to say what the host name ought to be for it. And when you create that service, it will go off and it will create all of your DNS entries so that the outside world can see your Kubernetes cluster with the name that you want rather than a randomly assigned ID for a load balancer, which is the very helpful default. For that, you will need your hosted zone ID that just kind of gets pasted in there. Again, the instructions I've installed. You know what? I'm going to go ahead and run this next one, and then I'll come back and tell you what it's doing. This next one, we're running another Kubernetes application called Cert Manager. How many of you have ever had to deal with SSL certificates? Everybody. How many of you have found the experience joyous? Fewer hands. So I want to change that. Cert Manager is a Kubernetes application, and the idea is two-part. There's one part where you create what's called an issuer. That is, there's a tool that will look for when you're asking for a certificate to be created, and it will create the certificate that you're asking for. There are some issuers, and there's a whole bunch that are already pre-built. You don't have to build any of these. So there are some of these that are things like, oh, you can have a self-signed key, and it'll create a self-signed key for you. This one works with Let's Encrypt. Do you guys know Let's Encrypt? It came around, I don't know, 8 years ago or so, with the idea that, listen, if you have control over your web server or you have control over your DNS entry, and you can prove that, then that should be enough for you to get an SSL certificate for it. And that's what I'm going to be showing off today. But what's great about Cert Manager is it knows when you have a certificate, it knows when it's going to expire. And it will renew it for you without you having to do anything whatsoever. Exactly. So this is why I love this. I didn't write any of this. This is the beauty of working in a big ecosystem like Kubernetes, though, is that you have tools like that available. All right. I hope that built right. So the next thing we're going to do is we're going to install the InterSystems Kubernetes operator. So this is a tool that lets you very easily set up an InterSystems Iris cluster. They can be very complicated. Our ones today are going to be very simple. There's a lot of documentation available. Obviously, I'm here to help if you have questions kind of about it, but we don't have time to go into the depth that I would like to on that. So I'm just going to install it, and we will move on. But when you install this, this is what Kubernetes calls a CRD, a custom resource definition called Iris cluster. It expands the Kubernetes API to know about these things called Iris clusters. And so when you create one, the IKO service will listen for that and say, oh, I know how to do that. And it will create the pods and the disks and all the other things that you need to run your Iris cluster. All right, so we've created IKO. And now we are done with all of our setup. So now it's time to create our first Iris cluster. The first thing that you need is going to be a few things. You're going to need to be able to talk to the InterSystems container registry, because that's where the Iris containers are. You're going to need a secret that is your Iris license key. You'll create that in Kubernetes. And then you'll create a config map of any CPF file or CSP merge file that you might want to configure your Iris cluster or to configure your web gateway. So I'm going to go ahead and create those. So the first thing is I'm creating a Docker secret in Kubernetes so it knows how to pull container images from ICR. And then I'm going to create a Kubernetes secret with my Iris key in it. And then I will CD. Very exciting. And then I'll create a config map that has a CPF file in it. And you can look over what's in the CPF file on the GitHub repo. It's pretty straightforward. And I'm going to create a service that goes with that. All right. So next up, we are going to, I just created the service. Creating this service, since it has this annotation on it, external DNS, it uses that external DNS application that we installed before, and it will create, based on what's in the service file, the host name. It'll create that DNS entry for you. And it'll take a few seconds to propagate through the network. And while that's happening, we're going to go ahead and create that SSL key. So here you see the Kubernetes YAML for a certificate. And we're telling it, hey, let's use the cluster issuer called let's encrypt-prod. And we're going to say, you know, the DNS name for my SSL key here is FHIR-TLS.bob.cloud InterSystems. It's actually different from that in what we're actually building. But let me go ahead and do that. I'm also going to create a self-signed key at the same time that we will use for the web gateway to Iris conversation. All right, now that's going to take a minute to, what did I do? That's going to take a minute to create the SSL key, because it's going off to Let's Encrypt, and Let's Encrypt is having a conversation saying, okay, I'm going to ask you to create a DNS entry with a very specific random chunk of stuff. And then when it notices that you've created that, then it'll say, oh, you own that DNS entry, and it will hand you the certificate. And that certificate is stored as a secret in Kubernetes. In fact, you know what? Why don't we see if that's been created? Should have a secret called FHIR TLS certificate. Oh, it is. Yeah, but it is not actually created yet because it has this funny name to it. And you can look up the events. It writes events into the Kubernetes log that tells you that it presented the challenge, and now we're just waiting for the certificate to be issued. The beauty of live demos, isn't it exciting? Oh, right. All right. It says domain verified, certificate issued. If I get my secrets, I will see one named FHIR TLS. Perfect. All right. So now we have everything that we need to create an Iris cluster. So let's go ahead and do that. How am I doing on time? All right, I'm not good on time. So I'm not going to show you actually what's in that, but it's all in the GitHub repo. But we're just creating a very basic Iris cluster. And if I do kube control get pods, you should see the FHIR TLS data 0 is initializing as we speak. And initializing really in this case means the disk is being created in AWS's Elastic Block Storage. I just defaulted to AWS's Elastic Block Storage. One of the things with Kubernetes is you have a million options for how to store your data. They all have different trade-offs: price, performance, reliability, disaster recovery, all those things. I see Cliff is in the room. Cliff Mason, raise your hand. Cliff has been testing, probably 50 different storage classes over the last 2 years for us. So if you have any questions about them, don't ask me, ask Cliff. handing work to my colleagues. All right, we're still creating the disk. That's not terribly surprising. So while that's happening, let's show what we're doing here, right? Over on the right-hand side, you see the YAML for the Iris cluster that we're creating. In there, you give it an image pull secret. That is the name of the secret that's being used to talk to the InterSystems container registry or whatever container registry your container is in. Below that is the storage class name, in this case GP2. As I said, this is an EBS volume that kind of default came with the cluster. The name of the license key secret, that secret that I created with my iris.key file in it. Config source, again, that config map I created earlier with my CPF in it. There's also this TLS section that's pretty new, that's new in IKO 3.5, and we're saying, hey, we want to configure the web gateway to use this secret that we just created called FHIR TLS. I probably needed a better name for it, but there you have it. And what that will do is that will configure the web gateway to use that SSL key. So that is the SSL key that you'll be using when you make web requests to it. And then the rest is topology. We say, hey, here's the web gateway. We want the Apache version. Here's the application paths that we want to configure. Here's the data node, is again very simple. And when all of that is done, just as a bit of an eye chart, I know, here's the Kubernetes resources that will be created by this one little YAML file. So there's quite a lot there. All right, how is my pod initializing? Ooh, I'm done. I have my data server and my web gateway all created. So now we're really cooking. Oops, there we go. All right, now we have our cluster created, all of our prerequisites completed. We have an Iris cluster installed on it. Now we want to configure that Iris cluster to run the FHIR server, and then we will secure it all with OAuth 2. So let's go over to here, and I'm going to show another feature of Kubernetes that I haven't shown you yet, and that's what is called kubectl exec. This allows you to execute a command inside any container running in your Kubernetes cluster. So in this case, I'm connecting to the data server, and I started an Iris session. I did all of this without having to install any SSH things or run an SSH server on my container. It's it's a much simpler path than you might be used to from VMs. And now I'm going to run the object script that creates and configures a FHIR server, and we are done. I could have built that into my container, created a Docker file and done all of that, but I wanted to show you this, this feature here. And this will be done in about, a minute or so. Oh, is it all? Yeah, well, that was one step that was complete. All right, Pat, you want to take things over on the OAuth side, and then we can.
Yep. Thanks, Bob. I think that was great. To configure that very complex infrastructure while we're talking is amazing. There's only a few more steps to configuring your FHIR server in the cloud with OAuth. And I'm going to just show you a few of those steps, but I'm not going to go into the programmatic methods that Bob used. You have to register the FHIR server as an OAuth resource. That's the first step in this. Once that's done, you have to create some clients on the OAuth server. Especially, you need to have a client for making requests, and you'll see that in a second. We'll need to get an access token to making FHIR requests. The FHIR server will validate that access token, and then we'll be able to basically issue a request. So let's just take a look at that. I'm going to minimize, let's bring up our cluster here. If you notice here, let me expand this a little bit. in a cloud deployment called FHIR.cloud.intersystems.com, and we're inside the management portal. And so what we need to do to set up OAuth is we got to go to System Administration and Security. We have to take a look at our OAuth server. And you see that we set up a OAuth endpoint for the, so that we could get and issue access tokens. We have a number of client descriptions that we set up, but the most important is this FHIR resource server. If you see, it's a resource server, and this name, the FHIR resource server, has to be the same name as you set up in, if we go back to our FHIR server, let's take a look at that. Our demo FHIR server, if we go to configure it, we'll see in the server configuration that if we want to use OAuth, we have to have an OAuth client name. That client name that you see here has to be registered, as you saw in what I showed you in the client descriptions. It has to have the exact same name so that the OAuth server and the FHIR server can talk to one another and validate the tokens that are being issued. So once you do this, I'm going to show you how we would then use OAuth from a typical FHIR request. So here, I'm looking at an endpoint to our FHIR Cloud InterSystems web server on AWS, and I'm trying to make a request to that endpoint. But I want to use OAuth 2 in this, and I think I'll show you here, where we've set the type to OAuth. But let's get another access token, because I'm sure the one I have is expired from this morning. So I'm going to get a new access token. Oh, well, it looks like it remembered that I had already.
That's what you get for testing.
Yeah, I tested this a while back. So effectively, let me tell you what it was should have shown if that token was expired. It would have redirected me to a login screen where I would have typed my credentials. With those credentials, if I successfully put those credentials in, it would have issued a token, just like you're seeing now. So I could say, go ahead and use this token. So I'll use that, and now with that token, that bearer token that I could show you here, let's see if we can see that access token. Yeah, right here. I could then send the request, and you could see here is a very simple request. I'm just getting patient 1. But I did this in a highly secured manner using OAuth. And so really that kind of completes the setup of our FHIR server in the cloud. Let me go back to the slides here. I think we just have a couple more things to end off on here. So, just some key takeaways I want to leave with you. Cloud accessibility of FHIR is wonderful, but you need to have end-to-end encryption to really make it secure. And we showed you that today. EKS and Kubernetes really helps deploy a FHIR server in the cloud. This is a pretty complex operation. Go to Bob's wonderful website. I've put a lot more documentation into it also, a guide that you could use, because I know there's a lot of steps that will be very hard to remember. The last thing is both frameworks do require a significant investment of your time, but if you're willing to put that time in, you could get a lot of very fine-grained control over the resources and tailor it precisely to your specification. So that concludes things. I just want to let you know there's some other presentations after this that you might enjoy, performing advanced fire validation, building a fire facade. And we have some other sessions on fire in the tech exchange that you might be interested in. I'm going to be doing later the fire SQL builder, but we also have things on R5 that you might enjoy as well. Here's some additional resources. You could download all of this and get access to all these resources, and Bob has already shown you the QR code. And then the last thing is help us choose a topic for an Iris for Health tutorial. If you want, you could look at this QR code, take a 2-minute survey, and we'll take your feedback very seriously in building the next Iris for Health tutorial. And with that, I'll stop and we could answer your questions.
There are no questions.
No.
It was perfect.
Right?
You understood everything as I flew by at 1,000,000 miles an hour.
Right. Just keep in mind, there may be questions that you can write to Bob or I. The website has wonderful directions. I could tell you it has saved me an immense amount of time. I set up a cluster without Bob's help, and it took me roughly maybe 4 times as long as his GitHub repo. So I would definitely strongly recommend taking a look at his documentation's really good.
Any other questions? Yes.
In terms of the amount?
My question is 4 times what? So you said it was 4 times as long. How long did it take you, the expert?
Well, a lot of it was from learning the AWS, EKS infrastructure and how to configure every one of those manifests correctly without using IKO. IKO absolutely simplifies the process. I could tell you this for sure. Can you do it without IKO? Yes. It will take you a lot longer to do it.
The two things,
Right.
sorry, the two things that you really, just to restate that, right? The 2 areas where you were stumbling was creating the Kubernetes cluster with all the right permissions attached to the right service accounts in Kubernetes.
Yes.
And EKS can do this if you know to twist all of these sometimes poorly named knobs. So in my EKS CTL config file that I have in the repo, it shows you all of those. And the other was you weren't using IKO.
Right.
And that was a personal slight, I think. Right? Any other questions? Brilliant. Well, thank you all very much. I appreciate your time.